All right. Well, thank you, everybody. We're moving right along this morning, and so I'm glad to bring to you some of the information coming out of the Habitat Task Group on behalf of Stephen Markowitz, my co-chair, and the rest of the folks. And as you can see by the logos up here, we have quite a few agencies that are represented with the task group. And just to kind of walk through that really quick, just to acknowledge everybody on the task group, folks from Michigan, Ontario, Ohio, Pennsylvania, New York, as well as our federal partners with Fish and Wildlife Service, USGS, and NOAA. So thanks to all these folks to kind of bring this stuff together and help wrangle this as I bug them throughout the course of the year. So for this presentation, we're going to talk about our priority management areas really quickly. Just kind of, we've talked about this quite a bit over the last few years. So just, if you're not familiar with it, or just to remind you about that project, because it's a big focus for that Habitat Task Group. And then some project highlights that came up from 2023, mostly ongoing projects that we've reported on in the past, but they continue to progress forward. So to hit first on the priority management areas, to kind of set this up and the premise behind why these priority management areas were developed, the Great Lakes Fish Commission Council of Lake Committees set up these environmental principles that, under the premise of sustainable fisheries can occur across the basin if functional habitats are protected or improved in each lake through a systematic, adaptive, cumulative, and collaborative approach that accommodates fish value in decisions to act on manageable anthropogenic stresses. And it's a lot of text on a slide, so I apologize for that, but it does kind of set the table for the priority management areas. And so, what do I mean by priority management areas? And using that premise that the Council of Lakes Committees developed, each Great Lake had to develop these priority management areas. And for Lake Erie, we took the fish species identified in the fish community objectives and pulled together a lot of biological information looking at the critical habitat components, the habitat impediments for various life stages of all of those fish species, and then try to identify remediation actions that could benefit those life stages of all those species. And then to add into that, we went to the LEC and asked them to help us, to give us their priorities of, what priority level do all those species have? Are walleye the same as gizzard shad? Definitely not. But we wanted to see how that, what those priority schemes would be and how we could score that out, as well as locations, on a regional basis across the basin. And so using those prioritizations with the biological information, we put that all together. And that allowed us to create some scores for actions that could be taken and in where those actions may be taken. And so from that, we had all these actions scored out. The LEC was then able to look at that, kind of cherry pick some of the top high scored projects and develop a prioritized list of actions and locations across the basin. So we started this out, again, text-heavy slide, I apologize, but it'd be really annoying to throw some pictures up of how we started this out because it was a massive spreadsheet, an Excel spreadsheet that is 300,000 rows large, and it just goes for column after column. So that was really hard to wrap our head around. Tons of information in there, really great information across the basin. But it was really hard to do much with. So we ended up developing a phased approach where we transitioned this into GIS layers that would be a little easier for LEC to use, as well as us to go through reviews and updates and some refinements and just simply wrap our heads around it and then give something to the public that they could see as well. And so this gives us a bit more of an improved ability to identify or prioritize areas. And we're working through the processes for doing these refinements. And we do have the GIS layers up. It's mostly for internal stuff, but we have had some, a good number of folks reaching out. And so that's, where it comes to identifying it as a really good tool. Not only did it get used to help develop the Lake Erie environmental priorities, but we've also been using it to help steer some strategic research directions surrounding fish habitat. And then we have a number of partners, various environmental groups around the lake that are coming to us asking for that information, which is great because it allows us to kind of bring our fisheries priorities and lump it in with their priorities as well. So it can see where those overlaps are. So with that, I'm not going to bore you with that anymore. We'll move on to some project highlights. And first, we'll start talking about some habitat suitability mapping that's going on. We got a couple projects that, these were reported on last year, but just for anybody who in this room that's not familiar with habitat suitability mapping, it's kind of the two projects I'm going to talk about are more focused on lake sturgeon, but can be applicable to other species if we understand what their habitat needs are, and these are in tributaries. So for these projects, they're looking at substrate surveys using sonar and bathyviewers. And then also looking at the depth of the tributary and flow going down at different stages throughout the year or throughout the spring, depending on what life stage they're focused on. And they take all that information, the substrate, the water depth, water velocity, and lump that into to develop these habitat suitability index models. And that's allows us to create some mapping. And an example of this is on the Cuyahoga River, where they did from the Gorge Dam all the way down to Lake Erie, over 70 river kilometers of digitized substrate. So it's a lot of information. They developed a flow model to understand those discharge rates and what that might impact, like with shear stress on eggs if they're deposited, things like that. And that allowed them to create this habitat suitability map. And what that map does is it gives us the opportunity to quantify some of the what habitat's available out there for these various life stages. Like you can see on this, I'm not going to go into crazy detail, but you have spring discharge and the percentiles on the bottom x-axis here. And this is the total area. And so for age 0 lake sturgeon, you can see there's moderate a decent amount of moderate habitat and a lot of really good habitat for age 0 lake sturgeon. For spawning adults, the amount of good habitat's not as high depending on how much discharge is coming down the river, but we still have a decent amount of moderate levels. And this is, this dotted line here shows the estimated area required for their population goals. And showing you this just as a really good example of we can take this information and then use that to develop the reintroduction plan for the Cuyahoga River. So that's some of the strong utilities for the habitat suitability index modeling. And another example of this is some work that's going on in Ontario tributaries, the Grand River, Big Otter Creek, the Thames River, and the Sydenham River. And so they're doing a lot of the similar work using side scan sonar to map a lot of the substrate information in these streams, using HEC-RAS data too, collecting temperature information to look at the thermal layers throughout the streams and pulling all of that stuff together. They've done a lot of this work already, and they're beginning to work through that, and will continue. And they have a good number of partners that are helping out with this, like most of the projects we have going on around the basin. So the idea is to then pull all this information, just like they have been doing on the Cuyahoga, into some habitat suitability index modeling. And this can, again, some of these projects were initially focused on lake sturgeon, but that can be applied to quite a few other species that are utilizing these tributaries, depending on what life stages and what information we need to have. So moving to another thing, we have, dam removals are a pretty common thing that a lot of us are focused on around the basin. We're going to report on update one anyways, that we had planned here last year, and it's the gorge dam removal on the Cuyahoga River. This was referred to as the single greatest unresolved water quality problem on the Cuyahoga River. This dam was built in 1913. It's about 400 feet wide and about 60 feet tall, so it's a pretty large dam. And it was installed as a hydropower dam, but that hasn't been in production. They haven't been producing electricity since 1958. And the interesting part of this as well is that the dam actually the pool behind it covers up a really cool waterfall and gorge that were there. So this dam removal and the sediment remediation that has to happen behind it is identified as the critical components for the Cuyahoga River to delist that as an area of concern. So this will be a good project to see finished off, and it'll help move that part of the needle forward. And while there is a waterfall behind it, I'll show you this in a second, but it is thought that this dam is, like most of our dams, is causing fragmentation of the fish species that utilize the river, and that's been going on for over 100 years. So just to kind of hit on those benefits, water quality improvements, recreational capacity improvements, and then the potential to get fish further up the stream, which would add about 18 river kilometers for the Cuyahoga River. And in this picture, that's the falls over here that I mentioned. So that's hidden by the pool behind the dam. So at a minimum, we get some aesthetic beauty back, even if there's still some questions out of what that will mean for fish passage to get to that extra 18 river kilometers. But that is a project that USGS and EPA are working with some fish telemetry on. And just to kind of give you the quick timeline on that one, dam removals can span for many, many years, decades often, especially some of these larger dams. But there's been a lot of work going on, and we're to a point with this one that in 2024 the sediment removal remediation stuff will occur this year, and then possibly into next year. And then once that's completed, they'll start moving forward into the actual physical dam removal. So good stuff moving forward, and kind of switch to lower energy areas and look at some wetland restorations. I got 3 projects to highlight really quickly here, and the first one's in the Sandusky, part of the Sandusky Bay Initiative. This is the Cedar Point Causeway Wetland. Again, these are projects that are ongoing. They don't happen very quickly. So we reported on this last year, and but this is they created these cells. You can see the north and south cell in the bottom left there, and they created those cells so that dredge spoils could then be pumped into here to build up the substrate in those cells that could then be planted. And once they're planted and all the plants are established, they could then breach those cells to allow fish access into those newly created wetland areas. So kind of a neat project, trying to figure out what we can do with all these dredge spoils, which it is a challenge for our partners at Army Corps and others around the lake. Another one that we reported on last year too was the McLean Wetland, which is part of the Rondo Bay area. And so, there were some long berms addressed with this wetland creation. They deepened out portions of the wetland, removed it was an old farm field, so they had to remove some infrastructure for moving water around and stuff like that there too. Did some bank stability work, and then the more recent stuff in 2023 was that they actually were able to get the culverts installed so that it could be hydrologically connected to McLean Drain, which then connects it to Rondo Bay. And then the final wetland one I'm going to talk about today is the Lake Erie Metro Park restoration that happened, and this one actually did get completed in 2023. It had been ongoing for a number of years, but they were able to restore about 1.7 acres of coastal marsh, and the marsh was largely inundated with the invasive Phragmites, so they had to initially get that cleaned, get that removed, allow the native vegetation to reestablish in there, and then to open up the marsh to more fish access, they actually dredged out a channel through the middle of it and then created some pockets to let those fish get into the marsh, as well as have access to some of that emergent vegetation that the coastal marsh provides. And in addition to that, the Metro Park has over 1,000 linear feet of shoreline that was largely just concrete riprap. So they removed that, did some really long grading. So it was like, I want to say it was 100 on one slope, really, really shallow slope. But that allows, vegetation to kind of flow as the Great Lakes water levels change, and it allows that shoreline to still remain softened while being able to handle a lot of the wave action that hits the area. And then a couple more projects to talk about with some habitat assessments that are going on. The first one's looking at the whitefish spawning, and could be looking at Cisco stuff like they talked about earlier, but lots of partners, like I said, as usual with a lot of these projects, especially these large projects. There's lots of different partners going on, but with this project, definitely focusing on whitefish. It's happening across mostly on the southern shore, but they're using egg mats and egg pumps at set locations to collect what they hope are whitefish eggs, and they're going out in the fall to collect these samples. And as they have they're doing this on grid cells, and as they're doing this, they're also identifying the substrate in the area, and the sites are selected using NOAA bathymetry information, as well as some bathymetric position index details that were highlighted as part of our priority management area projects. So with this work, you can see in this red circle, or maybe you can't see in the back, but there's a little tiny ag right about there. They're continuing to work through and process that substrate data, and then the future work is they intend to develop an occupancy model that will take into consideration the water depth, dominant substrates, water temperature, and as they process this all the data that they have, if anything else comes up that would be beneficial to include in that model. And then the final one that I'll talk about is our USGS partners are doing this public data on temperature and dissolved oxygen project. And this is really kind of leveraging the Great Lakes Acoustic Telemetry Observation System that we heard about yesterday in the central basin of Lake Erie, and putting temperature and dissolved oxygen loggers on the receivers that are deployed in that grid format where you can see these dots on the map. And they're doing this to measure hypoliminetic temperature and dissolved oxygen throughout the central basin. And the objectives of this are to supplement fish detection data. So, we're getting all the fish detections on these receivers. What kind of temperature and dissolved oxygen do we have at those receiver points? And then also to supply some detailed data for the NOAA hypoxia forecast model, which gives it some ground truth information for a retrospective analysis. And with that, I think I'm continuing our streak of being ahead of the schedule here. And I want to thank the Habitat Task Group for all the work. And if anybody has questions on this, feel free to reach out to myself or Stephen Markovitz, my co-chair. And we will, like Zach said, no one's banging on our door to get this report out, but it will be hitting the Fish Commission website soon.